Anchored retaining walls. How they work. Welcome back to Blueprint to Reality, the channel where we explore the engineering marvels that shape our built environment. Today, we're diving into the mechanics of a powerful and versatile structure, anchored retaining walls. These walls aren't just about holding back soil. They rely on tension, anchors, and precision to stabilize some of the most challenging landscapes. But what exactly are anchored retaining walls, and how do they work? Let's find out. What are anchored retaining walls? Anchored retaining walls are structures designed to retain soil at different elevations, supported not only by their mass or base, but also by additional reinforcements called anchors. These anchors, typically made of steel cables or rods, are driven deep into the soil or rock behind the wall and secured at the end with a grouted bulb or mechanical anchor. The key idea here is tension. By anchoring the wall into stable ground, these systems provide extra resistance to sliding and overturning forces, making them ideal for retaining large loads or dealing with poor soil conditions. Why use anchored retaining walls? Anchored walls are often chosen in scenarios where conventional gravity or cantilever walls just won't cut it. For example, when there's limited space for wall construction and the wall needs to be thin, when the wall must retain high loads or tall slopes, in areas where deep excavation is necessary, like basements or underground parking garages, or when soil conditions are weak and additional lateral support is required. The anchors essentially help the wall lean back into the earth, reducing the need for massive footing or wall thickness. How do anchors work? The anchors used in these walls usually consist of a steel tendon inserted into a pre-drilled hole and then grouted in place. This creates a bulb or bond zone within the soil or rock that resists pull-out. After installation, the tendon is tensioned and locked off, placing the wall in compression and countering the earth pressure pushing against it. There are two key zones to understand: the free length, where the tendon moves freely without bonding to the soil, and the bond length, where the grout grips the surrounding material. The effectiveness of the anchor depends on proper installation, tensioning, and bond strength. Types of anchored walls. There are several variations of anchored retaining walls depending on the wall type and how the anchors are used. Anchored gravity walls. Heavy walls that also use anchors for extra support. Anchored cantilever walls. Reinforced concrete walls with anchors to stabilize the stem. Sheet pile walls with anchors. Thin interlocking steel sheets driven into the ground and stabilized with tiebacks or anchors, and soldier pile and lagging walls. Vertical steel piles with horizontal timber or concrete lagging, supported by anchors to handle lateral pressure. Each type is chosen based on site conditions, loading requirements, and available construction space. Anchor installation process. Installing the anchors is a critical part of the system. Step 1. Drill holes at the required angle and depth behind the wall. Step 2. Insert the steel tendon or bar into the hole. Step 3. Grout the tendon into place to create the bond zone. Step 4. After the grout cures, tension the tendon using hydraulic jacks. Step 5. Lock off the tendon to hold the tension and connect it to the wall. This process ensures that the anchor is fully engaged and capable of providing the needed restraint. Monitoring systems are sometimes installed to measure loads over time and detect movement. Advantages of anchored retaining walls. Anchored walls offer many benefits, including the ability to handle high lateral loads in narrow spaces, reduced wall thickness and materials compared to gravity walls, adaptability to a wide range of soil conditions, suitability for both temporary and permanent applications, and flexibility in design, allowing for complex excavation sequences. This makes them especially useful in urban areas, deep excavations, and hillside developments where space and stability are top priorities. Challenges and limitations. Despite their strengths, anchor retaining walls come with challenges: higher cost and complexity due to the need for drilling and tensioning, the need for specialized equipment and skilled labor, the requirement for precise design based on soil investigations, and potential for long-term maintenance or corrosion issues with exposed steel tendons. Also, improper installation or anchor failure can compromise the entire wall system, so quality control is essential. Real-world applications. Anchored retaining walls are used in a wide variety of engineering projects, in highway and railway embankments, where slopes need to be stabilized without large structures, in deep basement excavations for commercial or residential buildings, in waterfront developments or dockyards where retaining structures must resist water pressure, and in landslide-prone areas where anchored systems stabilize slopes and prevent erosion. A famous example includes the anchored walls used during the excavation of the deep foundations for the Shard in London, where anchors help support massive loads in tight urban conditions. Conclusion: anchored retaining walls are more than just vertical barriers. They're dynamic systems that use tension and engineering precision to hold back the forces of nature. By anchoring into the earth, they allow engineers to build tall, deep, and safe structures even on challenging terrain. Whether holding up a hillside road or making space for a city skyscraper's foundation, these walls prove that sometimes the best support comes from what you can't see. Thanks for watching Blueprint to Reality. If you found this exploration into anchored retaining walls insightful, be sure to subscribe for more in-depth engineering content. No visuals, just solid understanding. Until next time, keep building smart.